Before I start with answering the question if it's compounded continuously, I'll first solve this if it's done, the compounding is done only annually. If it's done only, the compounding is only done annually, then we will only need algebra to solve for the interest. So what we do, interest is equal to the amount present after the some years minus the original amount which we deposited. That's equal to the rate times the time that passed times the original amount. So that will be, the rate is 0.02 times the years that elapsed, which is 10 minus 0, times the original amount, which is 20,000. That will equal 4,000. But what if it's done continuously? Then that means the t minus t sub o will be very much shorter, like it will approach 0. So if that happens, then we will have to add all of the small interest that we place, and then in order to get after 10 years how much interest will be earned. But of course that is very tedious. That's why we will apply differential equation to solve this type of problem. What we do first, let's go back to the original equation. So x minus x sub o can be written as delta x, while t minus t sub o can be written as delta t, and I just copied the other parts. Next, I divided both sides of the equation by delta t, so we will have delta x over delta t equals rx. And then if we get the limit of delta t approaches 0, since I mentioned that the time that elapsed will be shorter, very much shorter, approaching 0. And if that happens, then the delta x over delta t will transform into dx over dt. In order to get the amount x, we need to add all of the small parts. That's why we need to integrate both sides of the equation. But first, in order to do that, we should put all the x in the left side while all the t's on the right side. That's why I transpose the x here, and then the dt cross multiplied going there, and I just substitute the r to 0.02. Next, I integrate both sides. So from the initial value is 20,000. That's why it is on here on the below, and the x is what we're looking for. I placed it on top. Next, here the initial time is 0. That's why it's here. And then the time that we're getting the value of x is 10. That's why this should be 10. Next, we just integrate both sides. So the integral of this is ln x. Integrate from 20,000 to x. And then here 0.02t from 0 to 10. So we will get this equation, ln x minus ln 20,000 equals 0.02 times 10. And this will cancel out because it's multiplied by 0. We isolate the x, we'll have this equation. And then we just raise it both sides by e in here, and then we will get the value of x, which is equal to e raised to ln of this expression, ln 20,000 plus 0.2, which is equal to 24,428.06 pesos. But what we're looking for is the interest. That's why we should subtract the original amount he deposited in order to get how much is the interest. So the amount is 24,428.06. Subtract the original amount, 20,000. We will get the interest, which is 4,428.06. If you will notice, it's just a bit higher than if the compounding is done annually, because the compounding is done more frequently.
So the next question is how long will it take for Mark's deposit to double? So we also use the original integration that Andre used, but we changed the upper limit to 40,000 because we're finding for the deposit to double. So we use 20,000 for the lower limit because it is the first deposit and then it should be doubled. So we put 40,000 for the upper limit. And then for the right hand side, we substituted the 10 years to T because we're finding out how long will it take for his deposit to double to 40,000. So after integrating that, we should get ln of 40,000 over 20,000 equal to 0.2 T. And knowing that we got ln of 40,000 over 20,000, we could calculate that and then divide it to 0.2 to get T. We should get 50 ln of 2. It is equal to 34.66 or 34.66 years.
So in order to get the equivalent rate if the compounding is done annually, we will equate delta x to r times x times delta t. As what we have gotten in solving the first question, we have gotten that delta x is 4,428.06 pesos. And then our r, the r that we will use will be r over the year since the compounding is done annually. Our x will be 20,000, which was in the given, and the change in time would be 10 years because that's what is stated in the first question. And when we isolate r and solve the equation, we will get 0.02214 or 2.214%. This 2.214% would be our final answer for the rate.